project, we were tasked with designing and building a machine that actuates a tool to perform arthroscopic or endoscopic surgery. The machine was required to move in 3 separate paths: C1, C2, and C3. C1 and C2 simulate inserting and extracting a needle respectively, and C3 demonstrates independent motion in the X, Y, and Z directions. Our machine was modeled after a robot arm. The entire robot arm is supported by the base, which fits into the frame. A shaft sits on the X-axis centerline of the base plate, and a collar is press-fit around the shaft. A pulley is screwed in underneath the turntable, and a bearing is press-fit into the hole in the center of the pulley. A turntable pulley duo sits on top of the shaft. The robot arm achieves rotational motion about the Z-axis, which contributes to motion along the X-axis with its turntable, which acts as a revolute joint. The turntable pulley duo is driven by a belt and pulley system, which is connected to a motor that is mounted to a support table, which sits on the corner of the base plate. The support table is composed of 4 steel rods and an aluminum rectangular mount. There are nylon supports underneath the turntable to stabilize its rotational movement to stop wobbling of the turntable. The rest of the components of the robot arm sit on the turntable. The laser-cut acrylic base arms of our robot sit directly on the turntable and are supported with brackets. The 2 motors, which provide power to actuate arms 2 and 3, are mounted between the base arms. The base arms hold shaft 1, which is actuated by a belt and pulley system attached to one of the motors on a turntable and act as a second revolute joint. 2 laser-cut acrylic arms, colloquially referred to as arm 2, are attached to shaft 1 with set screws, such that they rotate with it. Shaft 2 is supported by the ends of arm 2, and it serves as the third revolute joint. This shaft is actuated by a belt and pulley system attached to a second motor of the rotating platform by an idle pulley on shaft 1. Attached to shaft 2 is arm 3, and a 3D printed arm with a socket on the end that attaches to a 3D printed ball mounted to the end of the arthroscope. The 3 independent degrees of freedom, X translation, Y translation, and Z translation, required to control the arthroscope, are achieved by actuating all 3 revolute joints simultaneously. This path is C1 and C2. It demonstrates inserting and extracting a needle. This path is C3. It demonstrates the 3 different motions possible: in, up, down, and side to side.
It's a solid thing. Now I'm a believer.